Hello, everyone. Welcome to the first technical session of the Akshwani Hæck. Thanks a lot for being here. We hope that this session we have prepared for you sets for you the first initial steps. Hello, you hear me?
We can hear you, yes.
Wait a moment.
I can also hear very well.
Hello? You hear me?
Yes, we still hear you.
Okay. Okay, so I was saying that welcome everyone. We hope that we enjoy this first session, technical session with Omar Saadoun that we have prepared. And it should be the first foundation for you to build on this hackathon. So I don't want to take a lot of time from Omar. Well, just let me introduce you. Omar Saadoun is leading the developer relationships in aeternity marketing. And today he will be showing you the unique advantages of aeternity and how to use them to build amazing applications that will allow you to have a chance to win one of the awesome awards that we have prepared for you. So without any more waiting, let's go. Omar, please delight our audience with your wisdom and knowledge, and thanks a lot for doing it. Thank you.
Thank you very much, Alex. Thank you very much. I'm honored to be here. The idea today is to take some little steps, but first I would like to talk a little bit about aeternity. So let me try to share my screen and let me know if you are seeing the presentation like
correct
now. Everybody
we can
see?
Yeah.
Perfect. Yeah. Awesome. Very well. So first of all, welcome. I'm so happy to have you all here, facing this new challenge that we have ahead and trying to work with our technology. For today, we have like a small workshop about how to start working with Sophia, the different techniques and technology we have for you to start working on your projects. But first thing I would like to do is to present very quickly, because we talked about this a lot of times, but it's always good to still explain about it and show why aeternity is the next generation blockchain. And mainly it's because it was made by thinking on all the different problems that everybody and all the other different blockchain has, and solve it from the ground, right? So that makes a very big difference. It's not the same trying to solve the issues I have while I'm facing it than knowing which are the issues I'm going to have and start from scratch solving that. And that way, with aeternity, we built a blockchain that is highly scalable, very fast, with very low fees on transactions. And it's not magic. It's software, it's team effort, it's planning, it's very good architecture, and all that combination make that we have a blockchain that is very easy to use, that of course has a lot of things to improve yet, and we have very good news in the near future. But right now you are able to work with oracles, with state channels, with generalized account, with a smart contracting language that is super easy to understand and very fast to work. And something super important is very low fees, right? But the low fees is not just a token price approach, but the way we execute our smart contracts, how our virtual machine works, how the Fate virtual machine works. So all that combination makes the possibility of having a very fast and scalable blockchain easy to use. Okay, so here are only some subjects. There is more deeper information even on the previous hackathon when we presented about our consensus protocol, that is Bitcoin NG, new generation, how we work. Sorry, how we work creating key blocks and micro blocks on every transaction, and how that makes very fast the transaction on chain. Well, again, our low fees on transaction, how we can scale off chain with our state channels, how to work with our built-in protocol oracles. And this is super interesting, and the main focus on this hackathon, right, is I have the possibility on the same smart contract, on the same blockchain, without any weird thing, without any external thing, to work directly with oracles, publishing my oracle, having my oracle, consulting querying my oracle. Of course, our naming system to make easy to read addresses for wallets, for contracts, for whatever I need. One special thing I like very much, and I hope to see some of those challenges we have ahead, is regarding generalized account. You have a default way to sign your transactions, and with generalized account you can change that way. So we have some challenges, especially for building some multi-signature mechanisms with generalized account. So really excited to see that. More information about our Fate virtual machine, how we process, how the relation of the Sophia code with the base code of the virtual machine works, and of course the main subject for us today, the Sophia language. So, and I like to do some practical approach, but it's very hard to do it without at least giving some points and some headline about what is Sophia. And Sophia, of course, it's our smart contract language. It's the language we are going to use to build our contracts, to run on the blockchain, to work with the data we have, to do all the different functions we need, all the logic we need on the blockchain. Also to use our oracles, of course. And Sophia, it's a functional programming language. So if you know something about functional programming and how it works, it's going to be super easy. If you don't, well, you will need to understand a little bit how the logic of functional programming is, but you will see that it's pretty easy. And always here, this is a good recommendation. Always try to do the simpler approach. Don't try to make it too complicated, to have like a function that does everything and solve everything, because that will make your challenge much bigger and hard to get. So always try to make it simpler, to try to make your problem in smaller pieces, and try to solve that way. Sorry. Well, how we build a contract? For us, a contract implementation is going to be the code for our smart contract, and it's a list of types, entry points, and local functions. That is going to be the way we manage our contracts in Sophia. We have like the result of our contract is going to be something very clean. You will see it's very clean, very easy to use. And of course, we have, because of the functional programming, we have like almost an error proof. So it's very easy to ensure that the function you are doing is going to work properly, and you can test it pretty easily. Okay, so it's like I have everything on one place. My language, my smart contracting language, is going to be helping me for anything I need to work with my blockchain project, at least from a smart contract approach. Some theoretical part, but also important to understand what kind of things I can do from Sophia. I can manage lists, I can manage maps, you can see like a hash map or a key value place to store data. But of course, I have other kind of types of information like integer, address, Boolean, bits, pretty much the usual I have, except for dates. Dates are also always like a pain for developers, but especially in this kind of environments. So you have like the main types of information of data that you can manage for your smart contract, like strings, You have a special one for list, you have tuple, you have record that is going to be pretty much used. You have, well, like I said, the map for key value storage. We have the option because there is no null, and this is very important on smart contract development. When I have something that is not defined, well, how I start? Well, in our case, we have the option to simulate that null value that is going to take the value none or something. Of course, the state is going to be the place where I store my information of the contract on chain. Then you have other stuff you can use, like events, of course, a hash, signature, and you have different elements to work with the chain, like, well, the chain time to live, the oracles, of course, the oracles to define the oracle, to answer a question, to query an oracle, and special definition about the contract if you want to use other contracts to do a remote call or stuff like that. But that is going to be a bit more advanced, and I don't want to put all that information today. Tomorrow we are going to have another workshop focused on oracles, and that's going to be more advanced. So at least today I want to give you all the minimum tools to start at least writing your own smart contract with Sophia. Very simple, doesn't matter, but the good thing is at least to have something that compiles, that I can deploy and I can try on the blockchain, on the mainnet, on the testnet, and starting to put in more difficulty on top of that, right? So following in Sophia, very important element is going to be the record. With the record, I will build my data structure to hold my information, to hold my logic, and to work with from the different functions I will have. Some example here on how to define a record. Very easy. You have like record account. You have to build the structure with the type. The way to do it is naming the record, and then the different elements I will have on my record is going to be like name, and then the type of that variable. Of course, you can combine, you can have record of records, you can do a lot of stuff. The way also to start the information on a record, returning that from a function, accessing to the information of a record, like the account name here. It's very easy, very straightforward. So once I get the three different rules we have, it's going to be very easy to work with. If there is something I need to do that is not like on the box, probably you will be using some libraries. There is some libraries that comes into the box, like the map, like the list, but there is others I can import. But let's keep it simple for today. For example, if I need to work with maps, I can do a lookup. I can do a lookup with some default value. I can check if there is a key member on my map. If I have to remove something, I have to check on the size, because we don't know the size of the map by default. If I want to build a map from a list, or I want to get a list from a map, I have some functions that will help me to do that. It's pretty the usual things we do on smart contracting. Also, how to do some switch. You can also do some if else, but the main recommendation here is always to remember that this is a functional programming, and you have to maintain that functional approach. So when you are working with the flow and on the logic, try to think if there is a different way than structured programming that I can do with functional programming. That would be my advice. I like very much to think about, let's say, for checking if there is something on a list, and I have to make the check on every item of the list, when maybe I can do some functional programming there, some recurrence to check that element, to change that element. So far, are we good so far? I guess if there is no question yet, I can continue. At the end of the session, we will have some space for question and answers. So keep that in mind, and let's see if there is some doubts at the end. Well, perfect. I have like the first ideas of how to do my coding on Sophia. Well, now where can I do this? How to start working with this? Which are the elements I have to work with? And there is like 3 different options that I if I want, I can combine, and I have the elements for that. The first one, and my recommendation is to start with our official online editor, the A Studio. Why? Because I don't need anything to start working with that. I just need a browser. So if you go to studio.apps.com, you will get the A Studio with already a pre-founded wallet on the testnet that you can use. And let me go there just for a second. Are you looking at my screen yet? I'm on the A Studio.
Yes, we can see.
Awesome. Perfect. Very well. So A Studio, and this is great work from Nikita. I don't know if you are somewhere here, but thank you for all this work. A Studio allow us to start working directly with both the testnet and the mainnet. So as you can see, when you start loading A Studio, I will try to start from fresh. You will have some test projects, some example that are already working that you can check, and you can see how they are made. What you can see here is, of course, the place where I'm going to be coding my contract. I have a menu where I can access the different files I have open on the A Studio, but on the right side I have the pre-founded account, like I said before, for the testnet, and as you can see, there is already an address already founded with some A tokens, some variables that my recommendation at the beginning is don't touch it, leave it like it is, and the different contracts you have compiled or you can deploy or use. And let's see if super easy to work. Like I have this contract here. Let's not worry about the content right now. If I want to deploy that content, I am the mainnet. Well, I'll go back to that. Sorry. I go back to the testnet. I'm deploying on the mainnet. Well, here I am. I'll deploy again. Well, I'm here. I can switch between testnet and mainnet. And if I'm on the testnet, I will use the pre-founded address. As you can see, I deployed a contract. Super easy. Just hit on the button deploy. My contract is going to be deployed. If there is no mistake, of course, on my contract, if it is compiled properly, if I do some mistake on my contract, I will see some compilation error right away. Okay, so let's go back to the good version. So always check about this, otherwise it's not going to deploy. It's going to show you the error. It's going to give you some hint. Most of the time the hint is right, but as you know, when there is some parsing involved for making the compilation of our program, sometimes, well, I have to check deeper and I have to see where my error is coming from. Also, if I have more than one error, I will have to double check. But I have this very good help about my contract. So once I deploy my contract, or I use our already deployed contract on the network, in this case, these are examples that come with the Studio by default. So many people already compiled those contracts, and you can use them from one of the compiled address and deploy address on the blockchain. In our case, we are going to be using the one we deploy already. And you will see that all the different functions I have that are public will be very easy to access and try directly from the Studio. So if I want to try very quickly, this is the way. But also there is a very interesting part, and it is if I want to generate the code to access from my JavaScript or my Node, I will do it with one button. And this is awesome for us when we want to develop and we want to take what we are doing on our studio. We want to grab this and put it on our project. So very quickly I can have the predefined code for accessing that. Of course, you will have to put the information about the wallet you are going to use. Please be very careful on how you store your private key. Don't let it public, of course, because otherwise somebody else can access your funds if they access your code and your private key. But you will have the different variables that you need to set up for using your contract from your JavaScript or Node project, and then you will have the execution for that specific function you have, right? So all the different parts of deploying the contract, getting the contract, and executing the contract, the function of your contract is going to be one button away, and this is super interesting to speed up the development. Okay, so my main advice here is start with Studio, work with the contract, understand how it works, how the logic of Sophia works, and then try to take the code to your project, to your own project. Okay. Here we are working on testnet, but if we want to go to the mainnet, what we have to do is to switch to mainnet. And of course, for that, I need to have my superhero wallet configured and set up, and of course, with some funds. So if you want to go to the mainnet from AI Studio, you just need to install your superhero wallet, get some funds there, and we are almost there. As you can see, I have my wallet address with the 5 A tokens I have, and here I can deploy, and I'm going to be deploying, of course, signing with my wallet because we are using the real stuff here. I will confirm my transaction and sign it, and I should be seeing right away my contract compile. Okay, so I compiled and deployed a new contract on the mainnet. Is going to be here, and if you don't trust me, you can go to the middleware, but could take some minutes. Explorer.
Quick question from the audience. Divyansh is asking, will there be example project developments?
There is already, and on our GitHub, github.com/aeternity, and you can see there is some let's say boilerplate where you can get the basics. Tomorrow with the Oracle's workshop, I'm pretty sure that Pivo is going to provide us some part about it, but also it depends on the language you want to work and the way you want to do it. I guess most people will work with JavaScript SDK, but anyway, that's up to every participant. So if you want to see, let's take the information. One thing I didn't mention, you have on the bottom part, you have all the different events, like message when something was made successfully, with when there is some error. So if you want to get into the details, you can check here, and worst case scenario, just turn on the console for developers and you will have more information. But usually with information I have here about a contract being deployed, a transaction being executed, and all of that, I will have the enough information. Let's see here, I have the address of the new contract I deployed on the mainnet. Here I am on the middle, where I am on the Explorer for the mainnet. So I should see at some point, here is my contract. So I just created this contract and I can see the information. So That way you can believe me that when I'm deploying my contract from a studio to the mainnet with my superhero wallet, I will get it on the mainnet for real. Okay, perfect. Well, let's go back to how to start coding. So first thing to use, and my main advice is start working with Studio, start understanding the errors of Sophia, how the coding structure, how the indentation it is, something I didn't mention, but we will do it. As you can see, when I have to do the indentation, I have at least to leave two spaces to have the right indentation, otherwise it's going to be doing some errors, like kind of Python indentation. So it's not going to be something totally unrecognized by the developers. But well, you will get those errors anyway on the editor, right? Like here, I'm missing a couple of spaces, and of course, it's telling me there is something wrong with your indentation. So check. Maybe you need to add some more spaces. Okay, so once I get my idea of how Sophia works and how to code and how to structure the information, I have other options to build my environment, because here we depend on a browser. We are working online. Maybe I want to do something with my own editor, and you have those options. You have some flexibility. You will see that there is the possibility of building your own local development. It's not the most the most quick version, but it's very flexible for you, because with a project, let's go back. With a project, I have the option of start my local environment where I can have the basic structure. I can have my contract source code. I can edit it with any editor I want. Like you have the Visual Studio Code that you can use with well, some help with the language. Maybe not as good as the A Studio right now, but you have some help. But you can code with any coding IDE that you want to use. And that way you will have like a local small network simulating and behaving like the real blockchain, where you can do your test suite, you can do all the different things you want to try of your smart contract, and being sure that you are doing the right way. So that you can access that through our GitHub. It's called a project, and you can see how to install it. You mainly need to have Docker install, the SDK, and a couple of more different elements, of course, a node and npm, and that's it. It's pretty easy to install. Other way is to that you have your local node, maybe testnet or mainnet, and well, you have your local node. You can push it there. You can work directly there. You will probably need a CLI that you can also get from the GitHub. I will give you all the different resources at the last slide, so don't worry about it. And finally, well, I don't know, any combination, the way you think is more suitable for you. In my case, usually I try to start coding on A Studio. Once I think I have a stable version, I go to a project, because all the different tests I want to do, I can have it coded on the same project, so I don't have to try it again and again and again and remember all the tests I was doing. It's just coded there, and I can improve and add more tests if I need. So and at the end, I will go and I push it and deploy it to the testnet. I will do my test there, and finally I will go and push it to the mainnet, and then that's the real thing. But it will depend on how you want to do it and what's the scenario of your projects and the needs you have. Of course, today we are going to be focused only on the studio, because we don't want to be messing around with different environment issues that you can have. By the way, if you are trying to use any of our tools and you face any bug, any issue, just tell us or just add it on the GitHub, push it on the forum, on Discord. We will be there to help you and to see. And if there is something that needs to be fixed, of course, we will be there also. Very well. So I talked about this before, but where I can see what I'm doing, what I'm executing, well, you have mainly the middleware to check on the testnet or on the mainnet. Well, new version is already here. This is old news. You can see which contracts are launched and deployed. You can see the transactions. You can see which channels are created, the different names, oracles. So you will have a very good idea of if what you are launching is deployed or not. You also have the command line that is kind of easy to use for different easy tasks. I like to check that for, well, if I need to inspect some specific transaction or working with accounts, creating some wallets, stuff like that I want maybe to automate, or I don't know, check. Well, you can use app.cli. You have also here the access on our GitHub. Super easy to use. It's just npm /e and install. So that is going to be super easy to install if you need it. Getting back to Sophia, well, as I said before, we have like as minimum structure and kind of elements we are going to be using on our contract, well, of course, the contract definition, the record where I have a special record that is going to be the state for storing all my information, but I can have all the auxiliary records I need to maintain my structure for the information. I will have another special entry point that is going to be the init that will start up my main structure and my state. And then I will have different public entry point that could be between stateful or not. And in this case, stateful for us is going to be changing the state. So if I do something that won't change the state, I don't need to put stateful. If I'm going to change the value of my contract and store it on the blockchain, then I will need to add the stateful keyword. In another way to see it, if I need to pay for a transaction because I'm writing on the blockchain, I need stateful. What is the basic structure? Well, definition of the contract, like we have here on the example, contract, name of the contract equals, and having one entry point that maybe doesn't write anything to the blockchain, like the hello world. Okay. When I start to work with a more extended structure of a contract, I have options to have my entry points only on one line without any block, or starting to work with blocks, where I will have to work with the indentation with 2 or more spaces to maintain the block. Okay. And at some point, we need to start working. I don't know how we are on time. I think we are pretty good. Here is suppose that you start working with me. So let's see how it goes. The idea is that you take your browser. You can get Chrome or Firefox, it's going to work well. And open the studio.apps.com. You will see that it starts with like 5 different new contracts. Just take one of them, empty the content of the contract, and you can start it. What we are going to be doing is a little bit more advanced hello world than the one we saw before, than this one, because we want that the hello world writes the information of my name on the blockchain. It's more than a hello world, is an say my name. So let's try to do that. I will try to do it myself on the meantime. If I can find where is the window. I think it's this one. No. Here it is. So when you start, you can just do Command A or Control A, remove all the information, and you can start from there. As I said before, the first thing I have to do is to name my contract, and I can put any name I want, like my new contract equals, and then I will go on the next line and start with 2 lines. So far, so good?
Yep.
Thank you, Marco. You are pointing out the visual, the coding help, right? Thank you for that. I will check on the question in the meantime. You have to do it. If you are a participant of a hackathon, you have to turn on that browser, you have to put that studioapps.com, and you have to start working and coding to see how it goes. There is no way to learn other than try it, failing, try it again until it compiles, and then try to deploy. So let's remember that we need, I will change the name, by the way. Are you looking at the screen?
Yeah.
Yeah, perfect. Which one? The one with the empty contract?
Yeah.
Cool. I will go back to the testnet. Perfect. So remember that I will need to store information on the blockchain. So I need to work with my state. I need to ensure that I have enough structure to store my name. So one way could be just having a place, having a variable, be a string, could be another. I guess for a name, the best idea is to have a string where I store my name. And if I have this, I will need to initialize that information. So entry point, I will work with a stateful entry point that is special for initializing. You can work with variables if you want to init a contract with default values or with variables that you want to pass through. But in our case, we will just work without any parameter. So I will tell my contract that when it started, when it's deployed, and this happens only the first time, and only once when I deploy my contract. So once I call the init function, is not going to be called anymore. And in this case, of course, I want to start with an empty name. So I will have, and remember, because I'm changing the state, I will need to have a stateful, and not just because this is the init, but every time I need to change values and store it on the blockchain. So let's go to another part. You see that it's the studio is helping me. Of course, this is nothing new if you work with different environments for developments. But anyway, it's a very good help when I'm starting to work with a language that I don't know. So now I will need an entry point that is only going to tell me which name is stored on the blockchain. So I'm defining the entry point, I'm telling the name of the entry point, I'm giving the return type of the entry point that is going to be a string, and I'm defining the content of my function. And here I will use an on-the-box library because I'm using string library because I need to concatenate. You can find the definition of the libraries that we have. You can find it on the documentation about Sophia we have. It's also on the resources. But anyway, I will share the link right now. In case of strings, just a second. We go to the chat. Yes, we have. That's right, Jan. You need to work with the indentation. It's 2 lines. If you can see, every time I go to the next line, 2 spaces, and everything after those 2 spaces is part of the block. Okay, so that's the way you have to tell the compiler that this line is going to be part of this block here. Otherwise, it's going to be outside. And if it is outside, it's going to say you that I'm finding something that is not called entry point. And well, that's going to be a problem. So as I was saying, I share the string library, so you can see how it works and what you can do with the string. In my case, I only want to do some concatenation because I want to have a nice response from the contract. And here I'm supposed to give back the value for my name that is on my state. So I have to call state and then go to the variable I have within the state in the way I built it. Okay, so state my name, and that's it. That way it's going to tell me the name is stored on the blockchain. Okay, so I will go because now I'm reading the information, but I need to write information. So I will make a stateful entry point where I will remember my name. And of course, I will need a variable for that will keep the same type. This time, I don't have any return type because I won't be returning anything. I just put this information and updating the state. And for that, I will need to open parentheses. I will need to tell which are the new values of my state. And it's very easy. Let's make it this way so it's not confusing for anybody, because this my names corresponds to the state, my name, and this one is going to be the parameter. And of course, if there is something like, I don't know, I'm making a mistake here, it will tell me that I'm doing some error here. There is some unification error. And it's pretty clear, right? I cannot unify string and integer. So I will try to check where is the problem. Okay, I have name here. This is a string. Here I have parameter that is an integer. Okay, this is the problem. I will solve it right away. Okay, so here I have, well, at least it seems to be a good starting version for something that will tell me the name I store and giving me back the information I need. Something here. Okay. Let's see if it works now. It seems that I'm having some issue, but I'm not seeing. Can you define string I? But I already corrected this. This is what happens when you do some live coding, right? We'll just do something just in case, because it's not okay. Everything looks fine. But anyway, I'm having some issue. Well, but I will do like, I don't know if you saw on those kitchen programs that are cooking something and they bring something that is already ready to show it, because, well, you never know what can happen. So here is my version is almost the same one that I was showing before. Anybody is having some issues right now?
Sadiq wants to speak, I think.
Okay, go for it.
Sadiq, you raised your hand.
I will take the opportunity to answer some question. This is your question, right? So a smart contract can be modified after it was uploaded to the blockchain, right? And yes and no. Because once the contract is deployed, there is nobody that can change it. That's part of the idea of a blockchain. What you can do is just edit your contract, fix it, and deploy it again, right? But that will mean that there is two different contracts. They are completely different because there are different contracts. Maybe they have the same code, maybe they have just one function different, but doesn't matter. It's going to be two different contracts. So every time we hit on deploy, it's going to stay there forever. It's funny. It's like we are feeling with testing on our testnet. But well, there is nothing we can do about it. Okay, so let me see why this is not. Maybe because I'm on incognito mode. Anyway, well, I will try to deploy here. The only two things I added here, I will mention, is a couple of controls which require. This is a way I can protect my functions from getting information that is not on the way I want, or maybe even if I want to check if the color of the function is not allowed. Let's say I have a function that I only want the creator of the contract to be able to use that function. Well, I can add that condition on the require. As a first line, I can add, and I can add as many requires as I want. I can add a require where I check that the contract creator address is the same one of the contract caller, right? So that way I can control who is accessing and who is executing my entry points. Okay, so in this case, I only added the control of the length of the name when I'm writing on the blockchain to have a name that is longer than 0. And in the case of saying my name, if there is no name yet, I will just tell that there is no name to give back. And it's just that. So now I have deployed my contract. I will try this. And well, let's try first to say the name. And here I have an error because there is no name, and the requires gives back an error with the message I put, right? This is not something that I will be using for showing error messages on screen, right? This is a smart contract. I have to keep my logic, but also I need a way to tell to the upper level that there is an error and what kind of error it is, so I can show something easy to read to the user. So the decoded error is going to be that you never said your name before. That could be that is because there is no name yet, so it's still empty, defined by empty, but empty, and you will have the response result in the check of saying my name. Okay, so I'm using again the string library. I'm using the length function, giving the state my name, and responding in case of this is true. I will tell, okay, you never said your name before. So now I will remember my name. I will send the transaction. Now I'm writing on the blockchain. And if everything went well, if I call back to say my name, I should have the return value. So now I have the return value that I wrote on the blockchain. I wrote on the blockchain my name, my entire name, and when I'm calling to say my name, it's going to tell me the exact value that I wrote. Okay, following your question, Eric, if here if I go here and I change this, and I say, okay, I will just return the value of the state. I won't do anything weird with information. I will not transform information. So now I will have to deploy again my contract. So let's save it here. I can see that this contract has an address that ends with TS. I will deploy because I changed the contract. I can't use it anymore. If I want to have this new version of the entry point, I will have to deploy it again. So I deploy again my contract with the same name, but it's going to be in a totally different address, right? So here it is, my new contract. And of course, it's going to start from scratch. So if I call to say my name, I should get the same error because there is no name. It's a new contract. There is nothing on the state yet, more than the init that is empty. My name is completely empty yet. So I will remember my name, and now I should see the new version of the entry point that I made. So I'm storing the value, I'm calling back to my name, and here it is. I only get the value without any transformation as I had before. Okay, so this proves you that I'm changing the contract, but as I'm deploying again, I will have a contract that starts from scratch on the blockchain. Okay, so far, are we good so far?
Here's a question from participants, the chat.
Okay, let's see. AK2YO. So are the two contracts both in their own linked blocks? The original still exists. The original still exists. Every time I hit here on deploy, it's going to deploy a new contract. So, and it's going to stay forever on the network. Doesn't matter if it is mainnet or testnet, it's going to be there forever. So you can, and you can see it. You can see it. You can see all the contracts that are just test. Well, actually, we don't know which are as test or not. We only know that they are on the testnet or on the mainnet. So, but every time I hit on the deploy button, well, I will have a deploy contract, and all the 300 tests I did before, they are already there and will stay there also. Very well. What else? Let's continue. So far, everybody was able to make this first version. Any issue? No, we will be using the GS SDK. I will provide at the end. You will use it. Perfect. Awesome. Very well. Let's continue with the presentation. And the presentation is more work, actually. I have here the version. I already show it on the studio. This is, of course, one possible version. The idea here is that you understand how to structure your contract, how to make your state, how you build that state, how you initialize a state, creating entry points, creating stateful entry points, and writing on the blockchain the different variables you need, and at least having some idea about the controls you can do easily for, well, different matters like format, like controls of the colors, different kind of things that you can do. But actually it's pretty interesting. Imagine that you have a contract that there is some entry point that you only want the creator to be able to execute, maybe to deactivate that contract, right? To disable it. So you probably have maybe just a Boolean variable that says enable or not. And then if you disable, you are going to turn off that variable. And of course, on every one of your entry points, you will have that required that will check if the contract is still enabled. So that way you can turn off your contract or turn it on. But of course, you don't want anybody to be able to do that. So the way you allow or disallow to access that entry point is by controlling that the color is the contract creator. How we are on time? We are good. We are good. We will have time for questions. Following hands-on we have is a little bit more complicated. The idea is to start working with lists. Usually we solve almost everything within lists, maps, and you are done. Of course, depends on the logic you need, but usually you work with that pretty much, and it's pretty much it. So the idea for this for this workshop is, again, using a studio, try to work with lists, simple lists, just with strings, and adding elements by prepending the element. A list works in a way that you can add elements on the beginning of the list, but you can also easily concatenate lists. So the idea is just that. Once again, I will go back. Let me see if I have here list element here. The way you can define a list is very easy. It's just a list, and you have to put the type of the list. In our case, it's going to be just strings, but you can also have tuples on the list. But that's a little bit more advanced. I will show an example anyway. So the first thing we want to do is to add an element. But first, maybe we need to build our main structure. So I will try to go with you guys. Let's start again here. I will use this one. Da-da-da. In this case, I will need to create a record state again, our special record, of course, that will manage. I think we don't need, we'll just need a list. That list is going to be string. Back here. And of course, I will need to start my contract in it. I will start. Here what I'm doing is returning the state. So the structure information I can see here is going to be the state the way it was defined. In this case, I will start my list with an empty, here it is, with an empty list. The way I can do that is by I always mix the different brackets and parentheses. So forgive me for that. Okay, so I have my init function. I have my state defined. I have a list that I'm going to be storing. Now, what I want to do is just add some element, some string element to the list. So I will create a stateful entry point. I can call it add string to list. My element is going to be a string. There is no return, but I'm changing the blockchain here, and I will put on my new state the new list. And of course, as I'm prepending, I will need to take care about that by telling that the new list is going to be the actual element I'm receiving by the parameter to the actual list I have on my state. So this way, I'm adding my element at the beginning of the state list I have. Okay, so I'm not losing any existing element. I'm just adding an element at the beginning of my list. Okay, well, now that I have that, I want to see it working. But for that, I need to get somehow my list. So I will have a public entry point to get my list. Oops. To get my list. This time, of course, I will be returning. And of course, this has to match with the type. But there is a mistake here. No. Okay. And straightforward state list, and that's it. So now I have the ability to add the strings to the list, but I also have the ability of getting my entire list that is on the state store. Okay, and last part I want to do. So far, we are good. We check questions. I can find the tab here. Okay, perfect. Seems like we're okay. So let's go back here. Here it is. So the last thing I want to do now is to combine two lists. But in this case, I will not be writing on the blockchain. So I just need to have a public entry point that will combine my two lists. Okay, so of course I will need to receive by parameter a first list of strings, and then my second list of strings. is going to return list of strings also. And we are going to solve this by easily getting my first list being concatenated with my second list. And that should be it. That should work also. We see my second. What's wrong here? No, it looks fine, right? Anyway, it's saying some error here. I'm having some refreshing issues, I guess. Or maybe I wrote something bad. I remember last time I was trying something and it was like, where is the error? Where's the error? There's no error. And finally there was some very small error. Let's refresh. Waiting for the testnet. Here it is. Okay. Perfect. Well, now I'm deploying. There was some refreshing error. As you can see, well, you can refresh the screen and it's going to grab the version. So I have my deploy contract, and let's just use the add string, the list. Seems like I'm having some issue here. Yeah, having some issue. Ready. That's I am the issue. So I'm adding strings to the list and I'm getting the list. As you can see, it's adding the element at the beginning of the list. Let's try this just in case. I usually don't try it this way. Awesome. And of course, here we are not writing on the blockchain because we are not storing on the state and we don't have an entry point that is stateful. But as you can see, I'm returning. If I want to store this information, this combined list, if I want to store it on the blockchain, I just need to do the same thing that I'm doing here, put in the state. Let's try it. My list, I will put it on the state. Done. Here I need one more space, I think. Oh, no, because I'm returning. So I need to remove this. Okay. Oh, as you can see, the error is telling me that I'm trying to do some stateful function, but I'm not telling the function that it needs to be stateful. So it gives an error. So now I have a new version that is going to be, let me copy this. I will deploy the new version that is writing the combined list to the blockchain. I'm deploying it. I'm getting the new version. If I get the list, should be empty. If I combine two lists, now you should get from the blockchain. And magical, perfect. So I was not lying. Oops. I have here, this is not the last one, this is one. I'm having the combined list stored on the blockchain. Okay. So we are almost there, again, this is one possible solution. It shows what you can do with some lists. As you can see, it's very easy to add information to the list, to combine lists, to work with lists. I have one more example on something I was working yesterday. Some issue that somebody has by working with maps. Let me see if I can find it. I don't remember if it is here. Working with lists here. This is a little bit more complex. The situation was that we had two different lists with addresses, and what we wanted to do is to create a map by using the first element of the first element from the first list as the key, and the first element of the second list as the value. And put that on a map. Remember, the map is a key value data type. Okay, so and the list it can store objects of the same type, or I can store tuples. So in this case, what I did is to first create a new list of the key value tuple, and then convert that to a map with the from list. And I did that in a recursive function by using the switch and checking if the actual status of both lists is empty. Of course, we are supposing that both lists has the exact length, okay, have the exact amount of elements, and the order matters here. So if I get the first element and of the first list and it is empty, I can check. I stop and return the empty function. Oops. But if it is not empty, I will get the first element and process it with the second list, checking again if it is not empty, just by control, because it's supposed not to be empty, getting the first element, and then build my new list. But how do I continue processing the list? With recursion, because this is functional programming. So I will call again the function with the tail of both lists. And when this is all processed, what I do is convert from list to a map. Okay, but these are a bit more advanced, but just for you to know that you can do a bunch of different things, playing with lists, maps, and recursion, and this is going to work very well, very fast, so no problem. Okay, so that will be the last part. My last slide is more about the different resources we have. As I said before, we have the forum, we have the documentation hub, we have the Discord channel that is here is the actual link, but otherwise just ask us for an invitation link and we'll provide. We have a specific Telegram for the hackathon. We have, of course, our GitHub, where all the source code are available of all the different projects. We have the A project for building your own local environment, where you can also have the A project installed there. The Java SDK, different Sophia examples that you can have, the Sophia documentation, and many more. But I think this is more than enough to start. Just a short question for you guys is, please follow our Stack Exchange proposal. Here is the link. But other than that, thank you very much. I hope I was as clear as possible. I know it's tough to learn some new language, but really in this case I think it's pretty easy to understand. But well, you need to try it out. You need to face the different errors. You need to hit your heads a little bit against the wall, as there is no other way to learn. So thank you very much again. If there is any questions, of course, I'm more than open to respond if I know the answer, of course. Questions? Come on, guys.
Not a question, but I would just like to point out that all of the slides that you've shown, they will also be uploaded on DevPost in the resources section. So no worries, you will also find them there. There's a question.
The init must be written. Depends if you have a different state. I mean, if you are having your own state, your own structure, then you need your init. If you don't need. In the case of AA Studio, I think it forces you to have an init. But if I don't have, let me grab another one. Let's say that you don't have any I'm just returning string. So here I have a contract. This is a smart contract. That's nothing, but it is a contract. I think it should let you, and yes, it's letting you. But it does nothing. It's not storing. But of course, if you have a minimum change on the state, then you will need to have your entry point. I'm not sure if it's going to give you some error or not. I think it's giving you an error. And I broke. This is for you, Nikita. I broke a studio. Let's go to the JavaScript console. Yeah. So answering, if you have a state of your own, then have your init function to initialize the values of your state. No, they are not all public. You need to add the public, or you can use the function. You can use the function also. Let's say, let me. Oh snap! Let me reload this. It's my entry. I'm just checking because there was some changes. Sometimes I'm getting old and sometimes I don't remember. So it's better to check. Here. Perfect. Let's deploy this. But you can have your private functions. My private function. Exactly. So if you want a function to be an internal function, you don't use an entry point. Actually, you don't need this. This is old behavior. It still works, of course, but your entry points are your public and your functions are your private. Let's try it again. So you have your entry points as public and you have your functions as, let's say, private entry points. In previous version, there were the possibility of using public, but that was changed some version ago. Cool. Thanks for asking. Asking was a good question because I missed the point.
There was also a question long time before, what's the meaning of entry point and stateful? But yeah, I guess we already covered that as well.
For entry points was covered. It's the public entry point of your contract. If you want to do some function that is going to be private, well, you can use private. You can use function instead of entry point. And in the case of stateful, it is when you want to write on the blockchain, you will change the state. You will need to add stateful to entry point or to function. What does it mean to call the function locally? Well, you will use it inside your contract. In example of, I think it's this one. In this case, this will be a function because I don't want anybody to use this function outside my contract because it won't work. I mean, I need to have a certain structure that I'm doing here with the get referrer of account. So what is going to be public is going to be this one, and of course this try and test, okay? But the listify just need to be a function because it's going to be called from the inside of the contract, not from the outside. So you can say that listify is a function that is called locally from the contract. Exactly. Function is private, entry point is public. Anyone else? In case you have more questions, feel free to share it through the yes. It's not that easy. That's a tough one. That's a tough one. No, we don't have inheritance. What you can use is to use interfaces. But that's it. It's not the same thing. And for random numbers, I invite you to build something. No worries, my pleasure. That's the way to share knowledge and also to learn, because when I'm doing this, I'm learning also. That could be. There is some theory that I'm not pretty keen on it, but there is because the idea is that when you call an oracle and you ask for information, it should always return the same information, right? It's not the case of a random number, but you can explore it. I invite you to explore because there is a lot of things, especially related to games and gambling, that needs random numbers, but also need to be transparent and need to be well, not easy to know it before. You know, if I can know which one is going to be the next random number, because there is some deterministic function where it's not going to be good for us. Yeah, it could be. But once again, I invite you to build something or maybe build the idea a little bit more on the theory, and that will be a very good question for Pivo. I remember we had some discussions about random numbers, so I think he's going to like that question and to answer it much better than me. Exactly. Yeah, we will have that oracles workshop tomorrow, and Philippe Pivo, he knows a lot about it, a lot. So I invite you to be here tomorrow, same time, same place, so we can learn about oracles and how to use it and see it in action. The most updated link is the one we sent. Let's send it again. Just 1 second. It's also on the GitHub, but this is a nicer interface for the documentation of Sophia. You're welcome. And I think we are on time, Eric, right?
Yeah, I think we're good.
Very well.
Or I think we resolved all of the questions. And yeah, the ones about oracles, I guess Philip will be the right person to answer them tomorrow.
Yes, definitely. It's going to be the place and the person for that. So let's grab that opportunity. Once again, thank you all for being here, for having some patience to hear me and understanding what I'm saying. I hope that I was clear and with enough detail, but not too much, so you can start working on your projects, on your challenges. And once again, any doubt, any problem, any issue, just contact me or contact us through the Discord from all the different channels, and we will be very happy to help. And I hope to see you all here tomorrow. Very well.
See you tomorrow, guys.
Thank you. See you tomorrow, guys. Thank you.